Welcome. Today we are going to simplify complex fractions. This section can be found in section 8.5 in your book, and I think it starts around example 5, so you have to dig into the chapter a little bit. So let's go ahead and get our notes out, and we'll get ready to go. Okay, objective for today is students will simplify complex fractions. And to simplify complex fractions, we have to understand what a complex fraction is. So let's take a look at that. A complex fraction is a fraction, so we're talking with a fraction. Well, we're having a lot of fractions in this definition. So the complex fraction is a fraction that has or contains a fraction in its numerator or denominator. So that simply looks like this. Okay, so if we break this down, we can see that in the numerator, there's a fraction. In the denominator, I have two fractions, and that's okay. It's a fraction expression. So again, a complex fraction is a fraction that contains a fraction in its numerator and or in its denominator. Okay, I'd like you to pause the video at this point and make sure you have the definition written down and the example written down, and then I'd like you to answer some questions in the form. Once you've completed this task, go ahead and start the recording back up or start the video back up, and we will continue on and learning how to simplify these things. So let's go ahead and do that right now. Okay, to start off, we're going to take a look at a word problem. This one's on physics, it's example 5, and you don't have to write it down in your notes. So let's go ahead and read it and see how it's put together. It says, let f be the focal length of a thin camera lens, p be the distance between the object being photographed and the lens, and q be the distance between the lens and the film. For the photograph to be in focus, the variable should satisfy the lens equation below. Simplify the complex fraction. Okay, so they have a word problem on focus and cameras, and they define our variables. They give us a lot of information up there. And sometimes when we encounter these problems, we're going, I don't know anything about this, but be aware our variables are defined, and really be aware of what are they asking us to do. Well, in this case, it's simply simplify the complex fraction. Well, what complex fraction? Oh, the lens equation given below. So they want us just to simplify this guy. So even though I don't know much about a camera and focus and even give us pictures and define everything, I don't need to know. They just simply want us to simplify this fraction. Okay, so we're going to learn two methods on how to do this, and once we learn the methods, we'll come back and do this problem. So let's take a look at method 1. Okay, method 1 says, if necessary, so if necessary, doesn't mean you have to do it all the time, but if necessary, simplify the numerator and denominator by writing each as a single fraction. Then divide the numerator by the denominator. So it looks like we have two steps. Okay, the first step, if necessary, is to simplify the numerator and denominator by writing each as a single fraction. Second step, then we're going to divide the numerator by the denominator. All right, let's go ahead and pause the video and answer the questions on the form. When you're done with that, we'll actually work out an example. So let's go ahead and do that now. Okay, so here's our first example. Let's go ahead and write it down. Our complex fraction is 5 divided by x plus 4, all divided by the expression 1 over x plus 4 plus 2 over x. So copy that down. Okay, so step 1 says we need to rewrite the numerator and denominator, if necessary, into single fractions. So I look at the denominator, and this guy needs to be written as a single fraction. The numerator's okay, but the denominator's not. So that's step number 1. We're going to rewrite into a single fraction. In order to do this, we need to look at common denominators. We're simply going to add these two up. So going back to our previous lessons and skills we've already learned, let's find the LCD and add those two up. Now looking at the two denominators, I can see I have an x plus 4 and an x. They have nothing in common, so my LCD is those two simply multiplied together, x times x plus 4. Okay, so let's go ahead and simplify it. So we have 5 over x plus 4, that doesn't change, all over. Now my new denominator will be, like we said earlier, x times x plus 4. And we need to rewrite the numerators. The left-hand term has an x plus 4 for the denominator, so it simply needs to be multiplied by x. So my new numerator for this term will be x. Okay, let's do the right-hand term. The right-hand term has a denominator of x. I'm missing the x plus 4, so let's multiply both numerator and denominator by the x plus 4. So I'm going to do the simplification here, actually multiply, that's 2 times x, plus 2 times 8 after we distribute it, 2 times 8, 2 times 4, which equals 8. Alright, so we rewrote the numerators, making sure you distribute through and simplify, and this is what we came up with. Now one more quick combining of like terms, and we'll be ready to move on to step 2. So step 1 was simply rewriting each to a single fraction. So numerator is 5 divided by x plus 4. Denominator will be x plus 2x, or 3x plus 8, all over. Now I'm going to leave this unfactored, x times x plus 4, because it's going to help us later on in the problem. Alright, step 1 is done. Single fraction, single fraction. Step 2, simply divide. Right, so to divide these, remember we invert and multiply. So 5 over x plus 4, change the sign to multiplication. And we should have, after we invert, x times x plus 4 as our new numerator, and 3x plus 8 as the denominator. Some quick cross-canceling, we can see there's some x plus 4s that go away. We have a 5. We can't factor out a number out of here, so we can't cross-cancel anything with the 5 or the x. So from here, it's just straight multiplication. So this will equal 5 times x, or 5x, all over 3x plus 8. And there is our simplification of the complex fraction. Okay, I'm going to go ahead and pause the video, or actually you pause the video and answer some questions on this problem. When you're done, turn the video back on and we'll go on to method number 2. So let's go ahead and do that now. Okay, so let's take a look at method number 2. Now, method number 1 and method number 2, it's going to be up to you which one you want to use. You're going to find whatever easier for maybe that particular problem, or just a method you might like best. So let's look at method number 2. All right, method number 2 says multiply the numerator and the denominator by the least common denominator, LCD, of every fraction in the numerator and denominator. Then simplify. One more time. Multiply the numerator and denominator by the LCD of every fraction in numerator and denominator. Then simplify. Okay, sounds easy enough. Go ahead and pause the video and answer the questions that go along with method 2, and then turn the video back on and we'll see how it works. Okay, here's example 2, or sorry, method 2. We're going to use the same example. So let's go ahead and go over this method. Now the method says find the LCD of all the terms in the numerator and the denominator. So if I look at the numerator, I have an x plus 4. Look at the denominator, I have an x plus 4 and x. So the LCD would be, for all terms, it's going to still be x times x plus 4. So in the previous example, we were using the same LCD to simplify the denominator. Here we have to consider all the terms in the numerator as well. We have to look at all three, and it just happened to be the same. Now, after this, it was simply multiply by this number and simplify. Now, if we take a look at what happens when we multiply, so let's rewrite the problem. I'm going to leave some space in between my terms so I can show the multiplication. Okay, so the concept of multiplying simply means I'm going to get rid of all my fractions. Multiplying by the LCD gets rid of our fractions. So when we're done, we shouldn't have fractions in the numerator denominator. It should be, there we go. It should be no fractions. They should go away. So let's take a look. Now with simple cross canceling, remember he's over 1. So I can go x plus 4, x plus 4 goes away. And I'm left with a 5 times x. That's my numerator, fraction gone. One more time. X plus 4's cancel each other out. Left with multiplication, 5 times x. Look at the denominator. Again, the x plus 4's cross cancel out. 1 times x is simply x. Plus, this time the x's will go away. The x's cancel each other out. And I'm left with, doing the distributive property, 2x plus 8. Okay, once we've multiplied by the LCD, we have no fractions. So now it's just about simplifying. The numerator is simplified. That's 5x. The denominator simply means combined our like terms. We get 3x plus 8. And we are now simplified. And that's method 2. It simply means multiply by the LCD to get rid of your fractions and just simplify. So let's go ahead and pause the video, answer the questions on the form, and when you're done, we will, or turn the video back on and we'll finish up the lesson. So go ahead and do that now. Okay, now that we saw method 1 and method 2, it's going to be your choice to use whatever method you'd like in simplifying complex fractions. I'd like you to try problems 11, 12, and 13. Use any method you would like. So I'm going to have you pause the video, copy these problems down, and try them on your own. When you're done, restart the video and I will run over quick solutions on how to do each one. And when I do my solutions, I like method 2, so that's the method I will be using to solve these problems. Okay, so go ahead and copy the problems down and pause your video, and when you're done, turn it back on. Okay, we're going to finish up by working the solutions out to these problems, and hopefully we can clear up any misunderstandings on the concepts. So let's start with problem 11. Here we go. All right, so problem 11, I'm going to look at using method 2, I'm going to find the LCD. The LCD for problem 11, let's see, 5 and 10, the common denominator for 5 and 10 is 10. The common denominator for 6 and 3 is 6. So common denominator between 6 and 10, why 60 works, the least common denominator will be 30. So I'm going to multiply each term by 30. And remember our goal. Our goal is to clear the fractions. So I'm going to rewrite this, leaving a little bit of space. And I'm going to multiply each of these terms by 30. Oops, that one didn't come out so well. So I'm simply going to slap a 30 up here and go and start multiplying. Now when I cross cancel, I know 6 goes into 30 5 times. And when I multiply them, I get 5x minus 30, or 3 goes into 30 10 times, multiply them, I get 10x. There's my new numerator, fraction's gone. 5 goes into 30 6 times, gives me 6x. 10 goes into 30 3 times, and multiplying by 7 gives me 21. Okay, so it looks like I can do a bit more simplification in the numerator. I have an x in this term in the denominator, none here, so 5x and minus 10x is negative 5x over 6x minus 21. Okay, look for any more simplification. Can I reduce? I notice I can pull a 3 out of the denominator, but a 3 won't help me in the numerator. So there's my answer. Okay, going on to number 12. So this was number 11. Number 12, I'm going to do the same method. I'm going to multiply by the LCD. It looks like the LCD of this one will simply be x. Remember, these guys are over 1, so I'm going to multiply everything by x. So 2x minus 4, remember this is 4 over 1, 2 over x plus 3 over 1. I'm going to multiply each of these by x. We can see with cross canceling, the first term will be 2, second one will be minus 4x, nothing to cross cancel. Same thing in the denominator, first term will be 2, second term, nothing to cross cancel. Can we simplify this even further, looking for combining of like terms, or can I factor anything out and divide out a common term? And looks like I'm done. So there's example 1, or example problem 11 and 12. Let's take a look at 13. Now you notice it's all about the LCD to get rid of the fraction. After that it becomes a little bit easier. All right, so let's erase and do the last problem here. Should we get it all? Okay, very last problem. Here we go. Number 13. Okay, the LCD. These I have a binomial expression, so I still don't have to do any factoring, but that's good. So I can see an x plus 5 in the numerator and an x plus 5 and x minus 3 in the denominator. I have some x plus 5s that match up, so my LCD is going to be x plus 5 times x minus 3. So if I multiply each term by x plus 5, and I'm going to go ahead and just slide this over, give me some room to work. I multiply each term by x plus 5, x minus 3, let's do each of them, x plus 5 times x minus 3. One more time, x plus 5 times, I'll put him out front here. I can do a lot of cross canceling. This x plus 5 takes out that x plus 5. They divide out. Then I can distribute through the 3. And my numerator becomes 3x minus 9. Same thing for the denominator. This x minus 3 with this x minus 3. And distribute. That would be 2x plus 10 plus sign. And the x plus 5 and 1 times x minus 3 is x minus 3. Again, LCD takes out the fractions. I'm left with nothing but fractions after I multiply, so while the numerator stays the same, I'm noticing that I can factor out a 3 if needed. So let's do the denominator, like terms. I get a 3x plus 13, and I threw in a little extra parenthesis, and I don't need that. I can't factor out a 3 here. I can't cross cancel out the 3x's. They're going to try to make you do that. Remember, these guys must stay together. Those are my two terms, and I am finished. Okay, so go ahead and wrap up the video and finish up the form. and hopefully we understand how to simplify complex fractions. If you have any questions, please jot them down in your notes and we'll answer them when I get back to class.